Hello and welcome to this video about VLANs. I'm Wolfgang Trammel and I run the DKICS Academy. If you want to watch more of my videos about or get more of the DKICS Academy content, just head over to our website and have a look what's there. Let's get started with the presentation. Networking Basics is a series of presentations about all topics for starting in network engineers, for people starting in the industry, or if you want to refresh your knowledge about networking topics. This is now part 2A. In part 2, I talked about Ethernet. Today, I'm going to talk about Ethernet and VLANs. But let's repeat a little bit about Ethernet. Ethernet devices, Ethernet connections in data center. You've all seen them. They are big boxes connecting hundreds of devices using optical fibers with speed up to 400 gigabit per second. And they connect a switch or switches and end devices. But Ethernet also exists in your home and connects what you have, connects a small router in your basement, connects it over copper wires with the computers you have at home. And also these switches, these small switches might exist in your home with copper connections connecting different systems over Ethernet. And let me repeat what a switch is. I talked about this a lot at the last video. A switch is an intelligent Ethernet device which learns what end device is connected on which port and only sends Ethernet frames out where they are needed. And if they have no idea where a device is, they broadcast the frame through all their ports. This is what a switch does. And Ethernet, if you remember the layer model I introduced in part 1, the Ethernet layer is on layer 2. It's called the link layer. Data units are called frames, and the purpose of the link layer is to provide a node-to-node data transport, not from here to Australia, but just from this desk to the next desk or to the basement. So really node to node. Ethernet, remember, it has a payload size of maximum 1,500 octets. There are jumbo frames, but they are not really commonly used. And Ethernet also uses an addresses, 48-bit long addresses, and to get them, basically a hardware vendor must purchase a block of addresses and they are burned into the hardware. So the addresses of Ethernet are usually hardware configured. Also, Ethernet is a broadcast medium. So all devices on one Ethernet segment can listen usually to all the frames. For example, if the switch hasn't learned where the device is, you can listen also to frames for other devices. So a broadcast medium, and all devices on one segment can communicate with each other. Let's have a look at the typical Ethernet setup in a home or in a small office. Well, you have a router somewhere. That's where your internet connection comes in. Often it's in the basement, and in Germany, where I live, it's often called a Fritzbox. And here we have my Fritzbox here on the picture. Then you might have an Ethernet switch on each floor. They are interconnected with cables, and perhaps in larger offices where there's more devices connected, you also might have an additional switch. And end devices are connected to these switches also using electrical Ethernet cables, twisted pair cables. You all have seen them. Now, keep in mind, again, Ethernet is a broadcast medium. So each device on this Ethernet can communicate with each other device. And Perhaps sometimes you do not want that. You might want to have, for example, guests on a separate Ethernet or your telephones on a separate Ethernet. There is a need to separate Ethernet either for security reasons or for practical reasons. You want a second network in your home. And I do have also more than one network at home. I have a separate network for guests. You might also want it for your telephones if you use IP telephony, or if you run sensors, these called Ethernet of Things, the Internet of Things. So intelligent devices also doing IP. Also, you might want to have separate. Or you have devices which you do not trust, which haven't received security updates for a long time, and you want to have them separate. So let's set up a guest network in our example building. Of course, one easy solution is to just duplicate everything. Put in a second switch on each floor and put in more cables, but well, it costs and also it's not very practical. So there must be an easier way to do that. And this is where VLANs, virtual LANs, come in. Let me show you how a virtual LAN in Ethernet is implemented. Remember the Ethernet frame? It has a source MAC address, a destination MAC address, and also has this Ether type field. Now, let's make the frame a little bit bigger. Before the Ether type field, we are inserting the so-called VLAN header. And the VLAN header identifies different virtual LANs on one physical Ethernet segment. The VLAN header contains also of a type field. It's 8100. Then we have a number of bits for administrative purposes, like a priority bit. And then we have the so-called VLAN ID. And that's 12 bits. So VLAN IDs from 1 to 4094 are possible. 0 and the last one are reserved. So what can we do with VLANs? You can have multiple VLANs on one physical infrastructure. And that would look like that. So you're running a second LAN on your physical infrastructure, and the systems on each VLAN cannot communicate with the other VLAN. And so you keep separate things separate. Connections between switches, they can have one or multiple VLANs on that. And if they carry multiple VLANs, they are also called a trunk. Now, how to set that up? Let's build a network. We have Ethernet switches here, example switch, and we are connecting devices to them, and we are also interconnecting switches. Let's have 3 switches. And let's have a router. And let's also have systems connected to these switches. This is where we start. This is a typical Ethernet without VLANs, everything on one Ethernet segment. Everything can communicate with everything. Now let's introduce 2 VLANs, a home VLAN and a VLAN for guests. We now need to configure the switches. We need to configure which port on which switch belongs to which VLAN. The end devices do not see that. For them, it's completely invisible. For the end devices, they just see I'm connected to an Ethernet port. So this is where we basically tell the switch, this is an access port. Access port means it's transparent to the end device. And we also tell the switch to which VLAN this access port belongs. And we are doing that for all the ports where an end device is connected. So it looks like this. The different colors represent different VLANs. Now we need to interconnect the switches. And of course, we want to have all VLANs available on, well, nearly all switches. So what we're doing now is we configure the ports interconnecting the switches as trunk ports. That means these trunk ports carry more than one VLAN, and also the VLANs are tagged. So the VLAN number is in the Ethernet frame. This is the command for that. And now we have a trunk between these two switches. The switch on the right side only has guest devices connected. So you might say we do not need a trunk here. But for the easiness, we also configure this as a trunk, but we also tell the switches to only carry the VLAN number 20, which is the guest VLAN. So also the frames on this trunk are tagged, and but the guest VLAN is allowed here. The next thing we need to configure is our router. There are two ways to do that. If you have, let's say, a sophisticated router, the router also can operate on a trunk. Basically, you are tagging all the frames, and the router itself takes them apart again, reads the tag, and can operate on that. So that's the first option. We have a trunk to the router. Now, not each consumer device can do that. So the other option is to have two physical interfaces on the router and have two access ports on the attached switch. So we're running basically an access port, two access ports to the router, one for the home VLAN and one for the guest VLAN. And that's how consumer routers often do that. Now, how does it work? How does the tag get into the Ethernet frame, and how do devices communicate with each other? Example number one is communication within the home network. So we have a device which sends out an Ethernet frame. Standard Ethernet frame gets sent out here by the device on the lower left, is received by the switch. The switch now adds the VLAN tag for the home network, VLAN number 10. Just making the frame green so you can see that. And it sends the frame to another switch, to the exit port, to the destination system, where the VLAN tag is removed and the frame is sent out as a normal Ethernet frame. So both end systems are not aware that there is a VLAN in between. Example number two is guest network to the internet. And again, the guest system is sending out a frame. It's received by the switch. The VLAN tag for the guest network, VLAN number 20, is added. It's sent to the top switch. It's sent, and here again, we're removing the VLAN tag, and it's sent out as a normal frame to the router, as we have here a router which is not VLAN aware. So we're using two interfaces to the router here. This is how VLAN works. The switches take care of the tagging of the frames, completely transparent for the end systems. Let's talk about what DKIX does with VLANs. We have these big devices connecting our customers. And the good thing is that VLANs can deliver multiple LANs on one port. We remember that I can have different broadcast domains, different Ethernet LANs on one port just by tagging them. And since most of our customers, well, all of our customers use professional devices, their routers can do that. And we are simply tagging different services, different LANs with a different VLAN ID. like we separated the home and the guest LAN, we can also separate different services. So a typical DKIX edge device, customers are connected over Ethernet, and the very basic thing is to deliver one service on one access port, like we deliver the Frankfurt peering service here. It's an untagged service in this case, and the customer participates in the Frankfurt peering LAN. But now he wants to have a second service on his port. So what we can do is we can tag each service. So we are tagging the Frankfurt peering service, and we are also adding a Madrid peering service and a New York peering service on the same port, each tagged with a different VLAN ID. So on your DKIX port, you can access different services just by enable trunking and just by having a different service delivered with each a different VLAN tag. But we can also do that for cloud providers. So for example, here we have a connection to a cloud provider, and you might see the VLAN tag isn't the same on each end. The DKIX edge devices can rewrite the VLAN tag. So we can deliver one and the same service on two ports with different VLAN tags, and the device does the rewriting completely transparent to the customer. Good. Conclusion. What did we talk about today? Please remember some basic facts about VLANs. Still, Ethernet is a broadcast network. So if you connect devices to one Ethernet segment, they can all communicate with each other. VLANs, they set up virtual LANs on a common physical infrastructure. So on a common physical Ethernet, VLANs take care of separation between virtual LANs. The VLAN IDs run from 1 to 4094, and one engineer once asked me for advice about VLANs, and I said, never use VLAN 1. Why is that? VLAN 1 is often configured as a default for new devices. So if you get a device out of the box, connect it to your infrastructure, and you are using VLAN 1, you will never know what happens. So please, if you have the choice, never use VLAN 1 for anything productive. Also, DKIX uses VLANs for multiple service delivery on one physical port. That's my presentation about VLANs. So thank you for listening. And keep in mind, you can also, of course, play with VLANs at home. So guest VLAN and home VLAN separation is the very basic thing you might be able to do. And otherwise, please have a look at my other videos. Thanks for listening. I'm Wolfgang Trammel, and thank you and bye-bye from the DKIX Academy.